Hello everyone, welcome to our webinar about GEOCLEDIAN's field monitoring service, Acknowledge. Great that you're all here. I will first give a brief overview about what we will do in the webinar. I will start with a short introduction about the BigDataGrapes project. This is the project in which frame this webinar is organized. Then I will briefly explain what Acknowledge is. That's our field monitoring service, how it works, and what kind of data, tools, and analytics we have available. And then I will hand over to my colleague Dimo, who will do a live demonstration of the tools and our API that we have available. After that, we'll give a brief outlook about current developments and do a short Q&A session. Maybe one sentence about us. I'm Florian Schlenz. Next to me is my colleague Dimo Dimov. We are both working for GEOCLEDIAN. We have some scientific background in remote sensing, GIS, geography, and computer science. And we now work at GEOCLEDIAN and trying to get remote sensing data into operational IT systems. If you have questions during the webinar, you can write them in the chat or in the questions dialog box. And if we have time after the webinar, we will try to answer them. If we don't have enough time for all of them, we will do the rest offline per email. Yeah, so just write your questions in the questions dialog. Okay, what is the BigDataGrapes project? BigDataGrapes, as the name already says, is a big data project about the grapevine industry. So in the frame of the project, it is EU funded. It's a Horizon 2020 project. In the frame of this project, we are trying to connect all kinds of data sets, very diverse data sets and large data sets that have somehow to do with the grapevine industry. And we are trying to connect them and to get new insights and develop prediction models for certain things. Our partners in the project are listed here. You can see them on this slide. At this point, I would like to thank our colleagues from OntoText who were organizing the webinar. And yes, I will now move on. In the frame of the BigDataGrapes project, we try to tackle different sections of the grapevine industry. These sections are, for example, farm management systems, table grapes, the table grapes industry, winemaking, and the natural cosmetics industry. They all are related to the grapevine industry, and we are trying to connect data sets that are relevant to all of these sections. What type of data sets are we using in the project? We are using all kinds of data sets that are available. These can be genomics data, weather data, sensor data from sensors in the field, bibliographic data, observations from the field, financial data and other logistical information, and also satellite data. And this is our part. We, as company GEOCLEDIAN, provide the satellite data sets for all vineyards that are being monitored in the project to the partners. And this is being done with our field monitoring service Acknowledge, and I will now explain how that works briefly before we go into the live demo. So what is Acknowledge? Acknowledge is a state-of-the-art satellite-based field scouting service. It is based on open data from Sentinel-2 and Landsat-8, and it is designed as a middleware for integration into IT applications like farm management systems, mobile apps, IX systems, governmental systems, and all kind of IT systems that somehow handle spatial data and would like to get up-to-date information from satellite data. Our system is easy to use and easy to understand, especially for IT people that want to integrate satellite images and analytics based on them into their applications. And of course, it works globally. So how does it work? From satellite image to information. Let's assume we have a farm or a plot, a vineyard, for example, at this specific spot in Italy, and we want to get information from satellites about this spot. How could that be done? So the classical approach would be to download satellite scenes for this spot and then extract the information for my field from the satellite scenes. And just to get a brief idea about what this means, a satellite scene is typically 1 GB in size. Downloading it takes some time, then I have to process it, then I have to cut out the field. And if I don't want to do that for one image, but for several images, for a whole time series, to monitor a season, for example, this would be quite a lot of effort and very time consuming. And this is exactly what our system does. So our system is designed to do object-based monitoring of one specific field. You can register any field globally in our system, and then we will cut out all the satellite imagery that's available for this field, and not only a few images, but the whole time series for the last 6 years, for example. And then you can get hundreds of satellite images. And from these satellite images, we can then construct a time series of different indicators that tell us something about the vegetation growth. So this is the basic concept. How does it work technically? You as a user or as an application, as an external application, can register the geometry of one field in our system. Then we prepare the data stack from all the satellite images. We cut out all the snippets for this field that are of relevance. We store them and make them available to you over an API, a REST API. And then you as a user or as an external application can get that information, you can view it, and you can analyze it. And you don't have to download terabytes of data, which we are storing on our servers. You just get a few kilobytes for the fields that you are interested in. So what kind of data do we deliver? We deliver, first of all, the visible satellite images. These are RGB images, the true color images like photos. And then we calculate a series of vegetation indexes from these satellite images. Of course, the satellite images not only consist of visible images, but we also have a series of spectral bands for every image available that tells us something about vegetation growth that we cannot see. And these vegetation indexes are, for example, the classical NDVI. This is a very known and a vegetation index that has been used extensively for decades, but there are much more meaningful indicators depending on what you want to know from your imagery. For example, the chlorophyll index that you can see below is highly correlated with chlorophyll and nitrogen. The NDWI, this one, for example, is correlated with vegetation water content. And there are other vegetation indexes that are correlated with specific vegetation characteristics that can be relevant depending on the application that you want to use them. Of course, you can also download the single bands, all the spectral bands from the satellite images, and combine them in the way that you would like to do. Of course, we not only deliver data and time series of data and images, we also do analytics on top of that. We have a series of products available. I will not present all of them here. I will just select, we will just select single products and show them to you. One example is our anomaly detection. This is an algorithm that allows you to compare fields, large numbers of fields, to find the specific fields that are interesting for you, that behave differently compared to the others. So we can take 10,000 fields, for example, in one area, and then we can take one field that we're interested in, we can compare it to all the surrounding fields, and we can filter all the fields that are that behave differently to all the other fields. But Dimo will present this live in just a moment. Then we will present. So the main goal of the webinar is to present our tools. So we want to show you how you can get access to this data, how you can look at it, how you can analyze it, and how you can download it to your computer. And Dimo will present our web client Analyst dashboard in a few minutes. This is useful to have a first look at the time series of images for one field and to do some first analysis, and then you can also download single images from from this client. It is available from our website for free. Another tool that we have is our QGIS plugin. You might already know QGIS. QGIS is the most widely distributed open source GIS system. It is available for free. You can download it, and it already has our plugin included. You just have to activate it. And if you have an account from us, you can then download all the satellite images for your fields onto your computer, and then you can do more sophisticated analytical stuff with it. My colleague Dimo will present in a minute how you can do that, and then we will show a very simple change detection procedure that you can perform in your GIS system. There are more tools that you can use, and also visualization components available on our website. You can contact me if you're interested, or you can simply go to this website. We have visualization components available that you can use in your web application that already help you to visualize and show and present the data to the people that you want to present it to. Okay. Of course, all of these tools only show part of the functionality that we have available. If you want to have access to all the features that we have in our system, and this is of course especially interesting for IT people, you can directly use our API. Our API is pretty simple. Dimo will demonstrate it in a minute, and you get these types of JSON responses from our API. This makes it very easy to integrate the data into all kinds of different IT systems. On the right-hand side here, you can see a few systems that use our data. These can be farm management systems, or governmental systems, or mobile applications, all kinds of IT applications that want to use satellite images. Okay, so let's move to our live demo now. I will hand the microphone to my colleague.
Hello everyone, hope you're still there. So my name is Dimo, the colleague of Florian. We work together at GEOCLEDIAN, and we both are responsible for the software development part and the analytical part of our Acknowledge software. And what I want to show you now is, first of all, our simple data visualization tool. So it's a web-based client that allows you to see the data in a graph-based version, and also in a cartographic way in a web map with a base map under it. So usually this egg client, as we call it, is available through our website, and each user has a specific ID. In this case, we use the project key of BigDataGrapes. And what you can do here is, for example, you can you have a split view, or just show the graph of the vegetation index time series of the different satellites. So here you have different observations of the time series, both indicated in different colors according to the different sensor types. So we have Sentinel-2 and Landsat 8. Of course, the availability of Sentinel-2 is much higher than Landsat 8 after 2017. So you can see the time axis here. This is a very long time series, and this actually already allows you for a visual interpretation of some crop specific indicators like crop performance or cropping intensity. Of course, if you split to the map, if you go to the map or just select the split view, you can view the different objects that we store in our database and that are fed with Earth observation remote sensing data and all kind of spectral indices that we derive from this multispectral and multitemporal data. The objects are available in a list for each user ID that I said it's already indicated here. You can select different parcels, so or bigger patches. We also store forest patches. In this project, we store mostly vineyards and grape farms. Yeah, so these parcels here in our project are mostly in Greece, France, and Italy. We have also some non-wine fields that we just show here for test purposes. As you can see, this is an Italian field. It's a test crop. You can see some attributes here stored in our database. For example, the crop type, the name, the entity, which is mostly the farm name or the region name, and then the area in hectares, and the seeding and harvest indicate actually the monitoring periods of these parcels, because you can choose different observation times, different length of a time series that's interesting for you. And you can already see that this parcel already, the time series indicates 2 harvests per year. So it's a main crop, probably winter grains, winter cereals, followed by some secondary crop. So you have a double cropping intensity in this case. You can also go through the time series manually just to look at the different green up and growth, crop growth stages. In this case, it's indicated by NDVI. So NDVI is the normal difference vegetation index derived from a spectral ratio from near-infrared and red multispectral bands. But we have also other spectral indices that correlate differently with different, let's say, chlorophyll contents, or also indicate plant diseases and water stress. For example, the NDWI is very much correlated to the plant water content. And it's also used for drought alerts and irrigation optimization. In this case, you can see that some parts of the field are a little bit stressed, and are probably due to management practices or irrigation that this has not been applied correctly in this case. Well, as already mentioned, we have different spectral indices. We have also visible image of the RGB, and what we can see also is you can toggle different imagery through animated time series. Yes, in the vitality. So it's a little bit slow, or you can just toggle manually through each individual data points. So now we looked at this specific parcel with this ID. They have all indicated through a unique ID. And now what we want to do is to show you the background of this web-based viewer. It's actually our REST API, where you can access the data directly, also automated, and you can feed all this data through requests, and you get a JSON response, as in the following example. In this request, actually you have the possibility to query all of your objects in a JSON list, and you can also access each of the JSON objects individually. As we said, we have this parcel in Italy, Virgiliana, and you can also access it individually through inserting the parcel ID into a new request. So the request changes from parcels, and then you have the individual parcel ID. The thing before is just the base URL of our API, and then and then the URL changes according to each different request. So in this case, we have the individual parcel, and it also shows the different attributes like the area, the crop, the entity, the monitoring period, also the centroid. So it is indicated by a point. But if you want also to query the individual geo coordinates of the different nodes of the polygon, because most parcels are polygons, of course, you can just indicate here a new request through geo format is WKT, which is well-known text. So the geometry of the polygon will be displayed in a text with the latitude and longitude. And you can already see that our parcel objects are all stored in latitude, longitude, degree coordinate system, which is WGS 84. Another possibility, of course, is not only to look at the parcel geometries, parcel objects, but also to show the different time series in a JSON response. So one parcel, of course, has many different observations, and all of these observations are actually corresponding to different spectral index time series. So you can add another request. So as we said, we started already with the parcel list, then we have the parcel ID, and for this parcel ID, now we can show different spectral indices like the NDVI, NDWI, the chlorophyll index, and other indices. In this case, the response of this request is a list of all available observations, the time series of for this parcel. And you can see that the output is, in this case, it's a PNG. So it's a color-coded RGB image of this spectral index, but of course, the imagery is also available in a georeferenced, so-called GeoTIFF format, which you can load in your geographic information system or any other system that allows for georeference data. You can see also the individual dates of the observation, and you can also automate this and query all the results through a script. Now, what happens if we want to visualize a specific image? Let's say I want to take this image here and to want to visualize it first in our browser. So for that, I just add another request, which is the raster ID. So one parcel has many different rasters or images, and they're all indicated through an individual raster ID. And we can just show a specific image here. So you can just select the individual one, and then if you specify the output format, you can visualize the PNG, the color-coded image in your browser, like that, for example. So you can see the green parcel, and it's already a good observation point. As we already seen, that's the 2nd of May. That's already well developed plant. But you can also change to another index. Instead of NDVI, you can choose a chlorophyll index that will saturate less than the NDVI, so you can see more heterogeneity within the field because of the different plant chlorophyll content in the field. So you can see actually the within field variation a little bit better, and it saturates also less. What will happen if you download, for example, with the TIFF? So if you indicate instead of a PNG, TIFF, then the system will just download automatically a georeference TIFF into your download directory. So I just indicated, and you've already seen that the download happens immediately. For this specific observation, parcel scene imagery, you have downloaded already a georeference TIFF into your download directory. Okay, I will come back later to this. Now we continue. You can also specify the different sensor type. So we have Sentinel-2 and Landsat 8 available. In the future, we want also to integrate other sensors like MODI, Sentinel-3, and also Sentinel-1. Then you have also the possibility, instead of querying different spectral indices, which are band ratios, basically, you can also have the opportunity to query the reflectance bands of the whole multispectral data stack, basically. So what you get back is a multispectral data stack with all 12 bands of the Sentinel-2 image, plus a cloud mask that allows you to filter those pixels that are contaminated by cloud and cloud shadows. Now, for example, another product, we cannot go through all of our products. We just want to show you those which are relevant for the project. BigDataGrapes is the one, as my colleague Florian already mentioned, is the Outlier Detection product, which is indicated by another request similarity. In this case, you get, as we already saw in the client, I can show in the client. For this image, it's also possible to get similarity metrics or so-called outlier metrics that allow to identify whether this specific object is an outlier or having some kind of anomaly. And this kind of anomaly can be due to different nitrogen application or different irrigation management, different behavior of the field according to maybe delayed start of season, different phenology, different variety of the plant, or maybe an occurred drought or pest or another disease. Or it can be also something positive. Maybe this is a positive outlier that actually performs better in terms of crop biomass than the other parcels or other fields in the area. And you can, for example, I can demonstrate the similarity function. You can see in the red graph visualizes the time series of the observed parcel, and the blue graph is actually a dynamically calculated reference NDVI curve in this case. So what we do, we compare both graphs and derive different similarity metrics. For example, in this our client, you can just see correlation and the spectral Euclidean distance. It's average between all data points. But we have also other similarity metrics like cosine similarity, covariance, and local outlier factors that allow you to have an array of different similarity metrics, and then you can also further process and derive. You can also, for example, feed them in a machine learning algorithm to make automatic assumptions about the outlier. The similarity function, which compares one field with its stored reference. We have for each crop, we have in field, we are storing a reference data in a background, and that is queried automatically. But you can also manipulate those reference curves by changing the search radius. So it means that starting from this parcel, the reference curve will be calculated only within a specific radius for this parcel. The interval means the interval in days for the temporal aggregation, because both graphs, of course, don't have the same dimensionality of data points through time. So in order to equalize both graphs in terms of dimensionality, we introduce temporal aggregation to average data points within a 7-day interval or a 10-day interval or whatever. You can also select the number of references that you get. Of course, the more references are dynamically calculated for the reference graph, and the less correlated it will be, of course, to the observed parcel. And you can also choose to compare this specific crop or vineyard with another variety. So it will show you how this specific variety or crop type will behave according to other crop types. So you can compare also, for example, wheat with barley or barley with maize, and maybe they are also have a good similarity indicators, which is also used for subsidies management. So in this case, you can also verify if claims of the different parcels are actually registered correctly or not. So that's used in subsidies management. Yes, and this exactly the same similarity function is also built in our system as a request from our REST API. You see the content temporal aggregated time series of the reference that's dynamically calculated, and the temporal aggregated parcel time series. Then some summary of the attributes for this specific parcel, and then the different similarity metrics that also can be analyzed automatically. As I said, we use them also in a machine learning approach. Well, so that's our main product for this project. For BigDataGrapes. Now we go back to the analysis of the data in a geographic information system. As I already mentioned, we downloaded manually a geo-reference TIFF image of an observation point for NDVI, and we stored it here in our download folder, and it is indicated by the raster ID, which is actually unique for a specific sensing time, sensing date. And we can just import it very easily in our QGIS, and for this case we use QGIS 3, the new version, and you can just add this raster layer here directly, and yeah, and you can see you can also query the different pixel values, as you can see here with the information toggle button, or you can also give some color coding to it through single band pseudo color, so it makes more sense to have higher NDVI values indicated by a darker green color than vice versa, of course. And what you can do, of course, is to download multiple images, also create your false color infrared data stacks or multi-temporal data stacks from many different NDVI images, and, for example, perform a clustering or derive farm management zone products and so on. But for this purpose, also to further analyze images directly into a geographic information system, we have developed our own plugin for QGIS that you can download from the QGIS official plugin repository. So basically, that's our tool, EGNO for QGIS, and for this purpose, you just have to know where your data is stored, because we have many servers. So you need the host URL of the server where your data is stored and your application key. So for this case, we are, as I said, we're using the BigDataGrapes application key. It's a hexadecimal, basically key. And you connect to the server, and all the images of this parcel are downloaded. And I already did it here for the specific parcel. So after connection, you are able to query in the individual parcels, and then all the available images are downloaded here into this table of contents. And you can just toggle and color code through this multi-temporal data stack. But what we want to show is just a very quick demonstration in terms of change detection. So what we want to compare is just make it a very quick raster algebra with those images, just a quick NDVI image difference between 2 points in time. Let's say you select the point in time before emergence or during emergence, and then you compare it with the point in time where is the assumed peak of season, and you can see actually the difference in NDVI, and through this it's also possible to see where actually crop biomass has developed more, and you can also correlate it with crop performance indicators. So let's say for this purpose we can use a raster calculator which is integrated in QGIS. It's a tool for raster algebra for making different calculations, which is with the pixels, because as you know, each pixel stores the actual data. Let's perform a quick image difference. Let's say for this parcel, you have also available all the time series. And let's go back to last year, where we have for this wheat parcel, as I think, we have the emergence around end of March, beginning of April. And you can compare it with the peak of season, which is around end of June for this parcel. So let's say we just subtract both data sets from each other, and you can also do another calculations. Let's say you can also do arithmetic mean of the images, so you can just sum up all images to derive something like an area under curve. Okay, if it was temporarily irregular, and this is also very much correlated to the crop performance and thus with the crop biomass. Anyway, you can do any kind of calculations and store the outputs locally. So I will just do it here. And you store it again as a georeference TIFF. You can also choose the output coordinate system. In this case, it's just the web-based WGS84, which is pseudo-Mercator. And yeah, you can just click, and then you have the result. And so I can just filter out this result here. And you can again color code the image as you like. To different colors are also available in from the color menus. Okay, so but we choose of course green for vegetation. And you can already see the different shadings also indicate a bigger difference. So we just performed a change, very simple change detection between 2 time steps. And you can see that darker pixels indicated by darker green are indicating a bigger change of values between both images. Yes. Well, so what we are also working on is also different products. We cannot show all of them. Let me just give you a short overview of the other projects that we're just currently developing. Just 1 minute, please. Come on, what is this? Okay, so do you see? No? What's going on? All right, okay. So another product what we are now prototyping and currently releasing and deploying in our operation system is the Phonology Analysis. So through this you can also have automated indicators of phonology for each individual object, like start of season, maximum of season, or integral of the time series, which is the area under curve, which is of course more correlated to the crop biomass. And we have also other phonologic indicators like the BBCH codes that we want to integrate in our system, like the milk ripening, the dough ripening, but that's for grain fields, so it's not so much related to the BigDataGrapes project. What we have also is a farm management zones product. This is of course related to the BigDataGrapes project. Through this you can see areas within the field that behave differently, or are, let's say, you can derive heterogeneity indicators for each field. You can see different crop performance or different biomass behavior within the field, which is caused by management practices or different irrigation, maybe also malfunctioning irrigation, or also patches which are not managed well, or have soil salinity, or are just having some failure during the sowing. So, and this farm management zones product will be also available soon, and it's also possible to derive potential yield zones and different crop performance zones to optimize actually the work of the farmer, and to give him more information also about zones where you have to put more nitrogen or irrigate better. But as I said, you can also look at it positively, not only negatively. It also shows areas which are already well managed and don't need to be improved anymore. So yeah, that's all from my side. I will just give the microphone back to my colleague Florian, who will share a few words with you. And thank you very much for the attention. And Florian will take over now.
Okay, so let's have a look at your questions. We are just now scrolling through the questions, and we'll see whether we can answer them now in the Q&A session. So one question was, is it possible to download the images also from the simple web client? I think Dimo showed it, but yes, of course, it's possible. You can, there's a download button in our web client, and So you can not only look at all the images and have a look at the time series, but every single image you can also download, like Dimo did in the API and in QGIS. So you can download the visual PNGs, but also the GeoTIFFs, the GeoTIFFs that you can use in the GIS system. Okay, so there's one question here. I will quickly read it out loud. In a given time frame in which the weather is cloudy and therefore the satellite images are noisy, I guess, how accurate is the calculation of NDVI and of the other vegetation indices? What do you do to tackle such situations? Okay, of course, we are working with optical satellite images here. This means in situations where we have clouds, we cannot see the ground, the soil. Therefore, we are filtering out all clouds. So we have sophisticated cloud masking algorithms that simply cut out all the images that are cloudy, so that you only get clean data. But of course, like state of the art in remote sensing still is that all of these algorithms only work to 99%. So we are filtering out, I would say, 99%. But every once in a while, it is still possible that that there will be some noise in the data. But we are currently developing a machine learning model that is trained very well to get rid of this problem soon. Yeah, but of course, depending on the region we look at globally, the data situation can be different. Of course, if we are working in the northern latitudes, for example, we can have a lot of clouds and therefore we get less images. In the Mediterranean, of course, we have more images because it's not very cloudy. Another question is, how could I receive recording of the webinar? Yes, the webinar is recorded, and you can just contact me. I will show my email address at the end of the webinar, and then I can give you access to the video. It will be available in a few days, I guess. And I see there's one more question. What is the spatial resolution of the data? So as we said, we are working with open data. This means that we have a lot of images available because the satellites that we're using overfly the same spot every 2 to 3 days in our latitudes. Therefore, we have massive data amounts, but the resolution is only around 10 meters, depending on the satellite I use. But Sentinel-2 has a resolution of 10 meters. Of course, we can also integrate higher resolution data in our system, but this is expensive, and therefore you typically don't have these dense time series that we are trying to investigate. There's another question just coming in. Is there a way for the user to retrieve or view pixel values of indices and bands for each different polygon? Yes, this is possible. Of course, you can retrieve every pixel value of every image for all the vegetation indexes. And if you want to go into more depth, you can, as Dimo demonstrated, you can download not only the images as PNGs, but also the GeoTIFFs directly as georeferenced images, for example, in your GIS system. And then, yeah, you also have the values there, and you can work with them. And I see there's another question coming in. Is it possible to get notifications if new satellite data are available? Yes, of course. As Dimo already said, in our API, there are much more features available than we had time today to present. So we also give out messages, for example, so that if you want to check in an automatic way, for example, if for one of your fields you got a new satellite image, you can request the messages for every field, and then you can see exactly when a new data update came in and when a new image is available. Okay. Okay, I think I answered all the question for the moment. If you have more, you can contact me. I will show my contact details here. If you have more questions, if you would like to use our service, just contact me. My name is Florian Schlenz, and you can see my email address here. Of course, you can also go to our website and to our Google sites where you get a more detailed product overview. Okay, Timo and me, we thank you for your attention. Thanks a lot for your time, and yeah, just come back to us if you have any questions, and hope to see you on the next webinar. Thank you.